Hey guys. So you might not realize that you already know what a neutralization reaction is, but you do actually from our lab safety protocols. For instance, if you spill acid for some reason, you know that you're supposed to sprinkle on that some sort of a base, and that those two will cancel each other out. What they do, in fact, is they create water and a salt. Right? So hydrolysis, which is the reaction that we're going to be talking about today, is essentially just the opposite of a neutralization reaction. It is putting water and a salt together to form an acid and a base. Pretty cool, huh? I'll just get rid of this bit here. We don't need that anymore. Okay. So, if we're talking, for instance, about sodium chloride in solution, right? Our reaction might look like sodium chloride. Again, that's sodium. That's a negative sodium ion plus, or positive rather, excuse me, positive sodium ion plus chloride negative ion plus H2O. Again, that's just water, right? Will give us, to some degree, sodium plus hydroxide plus the hydroxide negative ion plus a hydrogen anion or cation rather, and a chloride anion. So essentially we go from salt and water to this compound and this compound, right? And because the same number of hydrogen ions and hydroxide ions are released, the solution is going to remain neutral. They're going to remain neutral, okay? Now, one of the things that I want you guys to notice is if we were to look at a table of strong acids and strong bases, we would see that hydrochloric acid, so like this guy here, is hella strong, HCl, and that the hydroxide ion is very, very basic, right? So what that tells us, essentially, is that over here, in this lovely little reaction we just annotated, right? We've got a strong base and a strong acid, hydrogen or hydrochloric acid, right? So again, neutralization here, complete neutralization, because we've got a strong acid and a strong base, and they're essentially canceling each other out. But that's not always going to be the case. Let's take, for instance, the solution of zinc chloride, the salt zinc chloride in water. Okay, what we've got here is zinc chloride plus water. And when we have salt and water together, that's going to give us, guess what, an acid and a base. Now notice that in this case, we've got over here a basic compound, right? But it is still a compound. The hydroxide ions are being held in this sort of weakly ionizing compound, while the hydrogen ions, on the other hand, these guys are kind of floating free, right? And making the compound more acidic, the solution more acidic, right? So in other words, the salt of a strong acid and a weak base is going to give you an acid solution, right, when you have hydrolysis. So strong acid plus weak base is going to give you a solution that ends up being mildly acidic versus, remember up here with our first item, we had something that was neutral because we had a strong acid and a strong base. Okay. So let's say that we have Na2CO3 in solution. So how that would show up is you'd have your 2 sodium cations, right, plus your carbonate, your CO3 ions, in water. And that's going to split off. You're going to get essentially your double replacement, right? So you're going to end up with an acid and a base. So your sodium cations, for instance, are going to split off and go hang out with some hydroxide anions. And meanwhile, you're going to get some H's and your CO3 together in a weak acid, right? And that, again, this is all written as a single entity because it's a slightly ionized acid. Those two things are holding each other together, essentially, right? Because this is just faintly positive, and this is faintly negative, right? So you're getting a weak acid like that. But then you've also got these hydroxide anions running around. And remember, those are pretty darn basic, right? So whereas up here in our previous equation, we ended up with something that was mildly acidic, here we're going to end up with something that's mildly basic. Because guess what? You've got a pretty strong base and a weak acid. That's going to mean that in the grand scheme of things, you're going to end up with a solution that's a little bit more basic than it is acidic. Okay, so just to recap, what we've learned today is that hydrolysis is when we take a salt and some water in solution, the salts disassociates into an acid and a base. And there's a couple of different ways that can happen. If you get a salt that is a salt of a strong acid and a strong base, that's going to end up giving you a neutral solution, right? So for instance, NaCl has both a strong acid and strong base component, so that's going to give you a neutral solution. The salt of a strong base and a weak acid is going to give you a basic solution. The salt of a strong acid and a weak base is going to give you an acidic solution, and the salt of a weak acid and a weak base is going to give you a neutral solution. So in other words, when you look at the equation for a chemical reaction where you're dealing with hydrolysis, again, you've got salt and water coming into play, what you're looking for is for whether or not you've got an acid and a base that are both strong enough or weak enough to balance each other out, or if one is stronger than the other and so is going to show up as being slightly more basic or slightly more acidic.